The numbers here actually make sense. The last time I checked, the Sakhalin field that was developed cost them in the neighborhood of $24 billion. So when I say billion, I'm really not using it as shorthand for million. The numbers for current oil development are immense, which is also why it's worthwhile doing fairly in-depth analysis. So the knowledge we have at the moment is we think the probability that the field is actually dry is 60%. And the way we analyze this is first we put up a tree, and we call this project X. If we drill and the field is dry, we get minus 30, right? We paid 30. We didn't get any return. If it's a gusher, we paid 30, but we got $130 billion in return in oil, so we get a payoff of 100. Yes? There's a 60% probability of it being dry, so what's the probability that it's a gusher? 40. And the way we calculate the value of this project is by weighting the outcomes with the probabilities, which gives you what's called an expected value, and we'll talk a lot more about that next week, which gives you 0.6 times minus 30 plus 0.4 times 100, and that is 22. Now, you'll note that the field cannot actually give you an outcome of $22 billion, but it makes sense to use 22 billion when you're making decisions regarding the field, because if you're a company, you've got a lot of different projects. Some of them are going to be gushers, some of them are going to be dry, and they'll average out. And they'll average out around the expected value. So if somebody gave you an offer, if you had no other choice, there's no other way to get more information, and somebody gave you an offer of $25 billion, by this argument, it would make sense to take it. You'd be better off. But if somebody offered you 22 billion or 20 billion, you would not. Okay. Now, first exercise. Assume that you have the option of contracting with a firm with a direct line to the all-knowing. So, if you pay them, they will tell you if there's oil on the ground or not.
With certainty?
With certainty. And they never lie. It's always true. So, in that situation, you still have two different possibilities. It could be dry, or it could be a gusher, and these probabilities don't change, but you're only making up your mind after you know if it's dry or a gusher, right? So if it's dry, and you decide to drill, which seems like a foolish idea, then you're just wasting $30 billion in a very expensive hole in the ground, right? Or you could choose not to drill, in which case you get nothing. Of course, nothing is a lot better than minus 30, so if you're in this situation, which do you choose? Not to drill. If you're in this situation, opposite happens. You drill, you get 100. You don't drill, you get 0. So clearly, if you know that there's oil in the ground, you're going to drill, and you get 100. But now, you have an expected value that's 0.6 times 0 plus 0.4 times 100, or 40 billion. So the option of getting certain information, just the option of getting certain information, not actually getting it, is worth a lot to you. In fact, the value of your project is now 40 billion. So what is the most you'd be willing to pay in order to get that certainty?
40 minus 22.
89.
Exactly. So what's called the expected value of perfect information is equal to 40 minus 22, or $18 billion. And fortunately, there is competition, so you're not going to pay $18 billion to get that information. But on the flip side, you're not going to get perfect information either, right? So any questions on this structure so far? Okay. Now we get to the more fancy part. we incorporate the accuracy of the consulting firm. So now we're in this situation. 70% of dry fields will be recognized as being dry. 90% of gushers will be recognized as being gushers. But that still leaves room for error, yes? Okay. So, the question is, how do we build that in? And frankly, to my mind, it's better to just right away start with a table. So there are two things that the report can say. It can be either dry or a gusher. And there are two things that are true in actuality. It can be dry or a gusher. Now, before you get any report, you think the probability is going to be dry is 60%. You're always going to have a 1 here. And if that's 60%, this has to be 40%, because every row and every column has to add up. So how do we fill out the rest? That was rhetorical. We use these pieces of information.